So I'm going to give you guys a minute to get in, but I did just share the lab, and this is what it looks like. It's a little shorter than the previous one. We will be doing this optional section here, and I'm just going to kind of show you guys how to get started and get going collecting your data. So in the getting started page, if you guys click that down arrow, I want to watch and play this video for you a couple times so you can kind of see what's going on here. I'm going to play it without saying anything the first time. And then down. So I'm going to play it again and kind of talk you through it there. So 5 balls were thrown up in the air. They told you what each ball was. If you see right about here, the material, I'll pause it, a green rubber ball with a mass of about 80 grams, a lead ball with a mass of about 92 grams, a large steel ball with a mass of 535 grams, a small steel ball with a mass of 8.6 grams, and a styrofoam ball with a mass of 3.2 grams. Now, these balls have different diameters, different densities, except for the large and small steel ball, but it's very interesting how their flight path seems to be very similar. Now, what I want to talk about is kind of like the flight of free fall. I said it while, where's my soccer ball? I said it last class while throwing my soccer ball up, but you didn't really see what went on when it left the top of my camera here. So it wasn't that good of an explanation, or at least a good of a presentation. So what happens here, guys, is when these balls leave the hand, they leave at a pretty high velocity. And from the minute they leave the hand until the top of their journey, those balls are slowing down. So slowing down, slowing down, slowing down, slowing down, slowing down, slowing down, until they reach the top of their path, right there. And what happens, for a split second, right at the top of the path, the ball stops. So that ball stops right at the top of the path. And then it starts moving downwards. And from the second it moves downwards until the bottom of its journey, it is speeding up. So this is all balls, all free fall, everything thrown up in the air, being acted upon by the force of gravity, thrown up at a pretty high velocity, slows down, slows down, slows down, slows down, stops, and then speeds up, speeds up, speeds up, speeds up all the way down and keeps speeding up until it hits the ground. So there are 3 questions here. And for 3, you can use any one that you would like to. A second here, guys. So go ahead and answer these 3. Take out your trusty stopwatch here to answer number 1. And then you guys can use any ball except the styrofoam ball. So select which ball you would like to use for 3, too. I'll give you guys a couple minutes to do that, and then we will move on. One second, guys. You can stop, Alex. Are you guys done? You can answer in the chat if you're done or if you need more time. Okay. Seems that most of you guys are done. All right, so skip this graphing directions. We will watch those videos on Thursday and go right to collect your data and make a graph. What we have here should look pretty similar to our last lab that we did, the video where it's paused. We can use our tools and drag. The two tools are 5, come on, once it loads for me, 5-centimeter sticks, kind of right where the balls are thrown to help measure. This should be pretty helpful. And our stopwatch. So my advice is to put the stopwatch kind of over a ball that you're not using. If you guys selected one of these for it, and I hope you read where it said not to use the styrofoam ball on the right. It just said to select from these 4. So if I chose the small steel ball, I'll put my frame over here. If I chose the green rubber ball, I'd put my frame here, just out of the way of the measuring. So it says use the data table and graph to make a position versus time and velocity versus time graph of the motion of one of the spheres. More detailed instructions are in the section above. For this activity, it's important to use evenly spaced time intervals for your position measurements. Since the entire motion takes about 0.7 seconds, we'll measure the position of the ball every 0.5 seconds, so we get about 14 measurements. So first step is to insert row below until we have 14 data points. So I want everybody to do that right now. And there are my 14. I want you guys to name this position and this time. Fill in your correct units and variables. And then pay close attention here, guys. So I am going to use the small steel ball as my example. Fast forward to the frame in which the steel ball is released. So it looks like it comes off her hand right about there. We'll fast forward it to 0.5 seconds, 0.05 seconds exactly is when it leaves her hand. Use that time as t equals 0. And then use 0.1 seconds exactly like that as t equals 1. I know that can be a little confusing, but that's what we should have been doing the first lab. So then I would measure my centimeters there. Where did her hand start at that 0.5? She went from negative 75 centimeters to looks like negative 57 centimeters. And use this position as negative 75 centimeters to start. So go ahead and collect some more data. I don't want to give too much away for anybody that does have the steel ball. I don't want to do it for you guys, but enter the centimeters and go until you have 14 data points. Do not worry about your velocity versus time data yet. We will worry about that on Thursday. And the bell is about to ring in just 1 minute. So get your last measurement or two in there. And then thank you guys for listening so well, for paying attention. And thank you for all your effort in class. Thanks for doing that review with me. We will progress in this lab and a little bit more review on Thursday. We will do hopefully just review next Monday and then take that test next Thursday. So you guys should be all good to go with that. If you guys have any questions, you can always reach out and email me. If you're behind, if you need help on old assignments or your old lab, reach out to me anytime on Wednesday. We can meet. You know, we have those asynchronous Wednesdays. We have that Zoom hour from 9:30 to 10:30. I encourage you guys to come into. So that is what I would do there. You guys are, bell should be ringing any second. So you guys are good to go. Thank you very much.